Welcome back to Vuln Vibes. In this deep dive, we are going to talk about an elastic vulnerability. And yeah, this one's pretty critical. Hitting Elastic Cloud Enterprise ECE, it really demands immediate attention. We're zeroing in specifically on CVE-2025-37729. Now, this thing has a CVSS score of 9.1. That's pretty severe. So, for those of you running those big mission-critical observability stacks, that 9.1 basically means you need to move fast, like now.
Yeah, a 9.1 is, well, it's basically screaming full compromise potential, right? And what makes this one particularly nasty, even for really experienced teams like yours, is just the scope of the potential impact. We are looking at an administrative level flaw here, but once exploited, it pivots directly into server-side code execution, SSCE, and that's via template injection, which, well, that can lead straight to data exfiltration from your whole Elastic deployment.
That's the interesting part, isn't it? The core conflict. Because, yeah, we often see nines for like unauthenticated RCE, but here the prerequisite is you need administrative access to the ECE console first. So wait a minute. If an attacker already has admin keys, if they've popped an admin account, why does this flaw still get a 9.1? Isn't the game kind of over already?
That's a really good question. And it's an essential distinction to make, Getting admin creds is, of course, high severity in itself, but often that just lets the attacker use the system like a regular admin would, deploying things, configuring, viewing data, that sort of stuff. The 9.1 score here really reflects the escalation path. This specific template injection lets that admin user break out of the normal ECE sandbox. They can then execute arbitrary system commands, like directly on the underlying ECE infrastructure.
Oh.
So they go from being an authorized, albeit very privileged user, to essentially a full root level attacker doing SSCE, getting RCE inside the control plane, and then, quietly pulling data out. That difference, it's huge, catastrophic even.
Okay, right. That makes sense. So let's unpack the mechanism then. How does this actually work? It feels like, well, almost a classic attack vector, doesn't it? Targeting template engines. The official cause is improper neutralization of special elements in the Jinjava template engine.
Exactly, Jinjava. For listeners who deal with dev stacks, you'll know it. It's a common open source library, and ECE uses it pretty heavily for internal config management. Building deployment plans, setting resource sizes, defining node roles, all that. Template engines, well, they're designed to interpret stuff, configuration parameters, variables, and the root issue here is that classic template injection problem. The engine messes up. It fails to safely tell the difference between just plain user data and executable expressions.
Right. So an ECE admin, or the attacker acting as one, submits a config plan. They're basically passing a string to Jinjava. And if Jinjava's input cleaning isn't good enough, that string, instead of just being text, gets treated like a command. Sort of like SQL injection, but for the server's config engine.
Precisely. You're tricking the interpreter. If you can craft a payload using Jinjava's own methods, maybe to reflect system stuff or call underlying Java code, you just bypass the intended function entirely, and boom, you get code execution. What's kind of wild here is how deep this flaw is, affecting the core way ECE manages deployments. And that's why patching this isn't just recommended, it's like absolutely mandatory.
Okay, which brings us straight to the blast radius. Who needs to worry? Our audience runs complex setups. They need specifics. Can you give us the affected version matrix?
Absolutely. Crucial info right here. This hits ECE across two main active version tracks. So you are vulnerable if you're running anything from version 2.5.0 all the way up to and including 3.8.1.
Okay, the 2.5 to 3.8.1 range.
Yep. Or if you're on the newer 4.x track, specifically versions 4.0 and 4.0.1.
4.0 and 4.1.
Got it. If your ECE instances fall into either of those ranges, yeah, you're exposed right now. You need to act.
That covers a lot of ground. Okay, so let's switch gears slightly. From the vulnerability itself to how an attacker actually pulls this off, it's not just inject and when, is it? There's a specific feature they need enabled, the logging plus metrics feature. Why is that so important for the exploit?
Right. This is the key detail for detection and mitigation efforts. So the initial code execution, the SSCE part, that gets triggered when they submit those plans with specially crafted payloads. Basically, malicious Jinjava snippets tucked into the config parameters.
Okay.
But, getting remote code execution is kind of useless if you can't actually see the output of your command.
Yeah, you need feedback. You need that C2 channel.
Exactly.
Yeah.
You need to know if your command worked, and critically, you need to grab the data you just dumped or the keys you listed.
Right.
So the clever, scary part is how the vulnerability uses ECE against itself. When the injected command runs, the output, like shell results, dumped variables, maybe an API key, it doesn't get sent back over some new network connection, which might trigger alarms.
Okay. So how do they get it?
The attacker crafts the payload specifically to dump that output into the deployment's own logging pipeline. And because the logging plus metrics feature is turned on, the system just slurps up that malicious output thinking it's normal system logs or metrics.
Wow, okay, that's
Oh,
nasty. So the attacker, who still has admin access, just queries the logs, their own logs essentially, and pulls back the results of their system commands, completing the RCE and exfil loop, all using the platform's built-in tools, probably looking like normal activity.
that's exactly it. It's incredibly sneaky, keeps it all internal, bypasses typical perimeter defenses that look for weird outbound traffic.
Devastating.
And think about the broader risk here for the enterprise. ECE is often the central nervous system for observability, data security logs, app logs, maybe even PII, depending on what you ingest. So yeah, you need admin access to start. That sounds like a high bar. But if just one admin account gets phished or a credential gets leaked, the attacker suddenly has this path to total, potentially undetected control over huge amounts of sensitive data and the underlying infrastructure too. It turns an admin breach into a full infra compromise.
That level of exposure just screams patch immediately.
Yeah.
Let's get right to remediation then. What are the clean versions? What do teams need to upgrade to ASAP?
Right. The primary fix is the vendor patch. You
Yeah.
need to move quickly. If you're on that 3.x track, you absolutely must get to version 3.8.2.
3.8.2 for the 3.x users.
Correct. And if you're running the 4.x track, you need to update to version 4.0.2.
4.0.2 for the 4.x users.
Got it.
Those are the hardened versions that fix this specific issue. And for folks who like the technical details, what did Elastic actually do in the patch? How did they fix this Jinjava problem? Was it just blocking bad strings or deeper?
It seems like it was more fundamental than just a blacklist. The release notes talk about hardening Jinjava's variable evaluation, which basically means they beefed up the internal parser. They put in stronger filtering, better neutralization of those unsafe constructs, the function calls and special characters that let the payload jump from being data to being code. So stricter enforcement of that boundary between config settings and system functions.
Makes sense. Okay, patching is number one. But what if patching immediately is hard? Complex change control, critical prod systems.
Yeah.
Are there immediate mitigation steps?
Yes, there are a couple of important things you can do while planning the patch. First, and we always say this, but it's critical here, review and really tighten your admin access controls for the ECE console. Hardware MFA, least privilege reviews do it ruthlessly. Limit who can even attempt this.
Good security hygiene, always.
Always. Second, remember how the exploit relies on that logging plus metrics feature for exfil?
Right, to get the command output back via the logs.
Exactly. So if you have deployments that are maybe less critical or perhaps untrusted for some reason, you should consider disabling the logging plus metrics feature specifically on those deployments. Now, this won't stop the initial code injection attempt if they have admin access.
But it breaks the feedback loop.
Precisely. It cripples their ability to read back the results. It disrupts that crucial C2 and data exfil phase, makes the exploit much less useful.
Okay, good tactical move. Now, for the blue teams, the threat hunters listening in, is there a specific indicator, like a log signature, they should be hunting for right now?
Yes, and this is super valuable for active monitoring. Elastic provided a specific query. Admins should set up alerts or run hunts, looking in the request logs for payloads with specific names. The search query you want to use is payload.name, int3appear 3t3r, or payload.name for path.
Okay, let me repeat that. Payload.name int33t3r. That's interpreter with numbers, or payload.name for path.
That's the one. If you see hits on int-repeat 323r or 4path in the payload name field, that's a very strong indicator someone is trying or has tried to exploit this specific Jinjava flaw. If you see that, yeah, you likely have an incident on your hands. Time to activate the IR plan.
Excellent. A concrete IOC to hunt for. Okay, let's wrap this up. So we've dug into CVE-2025-37729. It's a critical 9.1 CVSS template injection flaw in ECE. Needs admin access to start, but then allows full server-side code execution and data theft. Key points. It abuses the Jinjava engine and uses a logging plus metrics feature for exfil. Patching to 3.8.2 or 4.0.2 is the main fix, followed by locking down admin access and potentially disabling logging metrics on non-essential deployments.
That nails the immediate actions. But maybe one final thought to leave with you, our listeners. Something to chew on after you've patched. This vulnerability wasn't really in Elastic's own code, was it? It was in Jinjava. a third-party open-source component buried deep inside a critical infrastructure tool. So the bigger question this raises, especially for mature security teams like yours, is what processes do you have or should you have to really audit the security of these embedded third-party components, these template engines, interpreters, stuff you didn't write, but that runs with high privileges inside your critical systems? How do you get visibility and assurance there? That whole supply chain dependency, it's a recurring theme, isn't it?
It absolutely is a really important question about understanding what's actually in the tools we rely on. Something for all of us to think about regarding code review and supply chain risk. Great point. Okay, thanks for joining us for this deep dive into CVE 2025-37729. Take these insights, check your versions, apply those patches, and hunt for those IOCs. Stay safe out there. We'll get you on the next one.